Hello students, welcome to Sorosor classes. For detailed information about our classes, you can just visit our website, that is www.sorosorclasses.com. And for other doubts and queries, you can call us or WhatsApp us at this number 9836793076. You can even like our videos and subscribe our channel for further more videos. Today we are solving some questions on rotation, and here is our first question. The question is, a particle of mass m, here the mass of the particle is given, that is m, is projected with a velocity v making an angle of 45 degree. It's making an angle of 45 degree with the horizontal. The magnitude of the angular momentum of the projectile about the point of projection when the particle is at its maximum height is, now four options are given, and the options are option A, that is 0, option B, that is mv cube divided by 4 root 2 g, option C, that is mv cube divided by root 2 g, and option D, and the last option is m root 2 gh cube. So now let's proceed to the solution. Okay, first let us draw the figure. Here this is x, this direction is y. Now this is it. We have to draw this to find the height, and here it is v cos 45 degree. Putting the value of cos 45, we can rewrite it as v by root 2, as the angle was given in the question, that is 45 degree, and this is h. So here is our figure, and we can write it as L is equals to m into v by root 2 r. Here r is equals to h, that is v square sine square 45 degree, as the angle was given in the question as 45, divided by 2g, that is equals to v square by 4g. Now we can rewrite it as L is equals to m into v by root 2 into v square divided by 4g, that is equals to m v cube divided by 4 root 2 g. Here this is our answer, and option B, that is mv cube divided by 4 root 2 g, is the correct answer. So here the magnitude of the angular momentum of the projectile about the point of projection when the particle is at its maximum height h is mv cube divided by 4 root 2 g. Here is our next question, and the question is, a thin circular ring of mass m, the mass is given, that is m, and the radius is also given, that is r, is rotating about its axis with a constant angular velocity, that is omega. Omega is the velocity. Two objects, each of mass m, are attached gently to the opposite ends of a diameter of the ring. The wheel now rotates with an angular velocity, and here four options are given. Option A, that is omega m divided by m plus m, omega into m minus 2m divided by m plus 2m. Third option is omega m divided by m plus 2m, and the last option is omega m plus 2m divided by m. So now let's proceed to the solution. Here we can write this as I1 omega 1 is equals to I2 omega 2. Now from this we can write that omega 2 is equals to I1 by I2 into omega, that is equals to mr square divided by mr square plus 2m r square into omega, and we can write this as m divided by m plus 2m into omega, or simplifying this we can write it as omega m divided by m plus 2m, which is in option 3, that is omega m divided by m plus 2m. So here the wheel now rotates with an angular velocity of omega m divided by m plus 2m, and this is our answer. Let's proceed to the next question, and it's a very important question and it's so simple. The question is a horizontal circular platform of radius, the radius is given, that is 0.5 m, and mass of 0.45 kg is free to rotate about its axis. Two massless spring toy guns, each carrying a steel ball of mass 0.05 kg. The mass of the steel balls is 0.05 kg, are attached to the platform at a distance 0.25 meter from the center on its either sides along its diameter, that is given in the figure below. Now each gun simultaneously fires the balls horizontally and perpendicular to the diameter in opposite directions. After leaving the platform, the balls have horizontal speed of 9 meters per second with respect to the ground. The rotational speed of the platform in radius per second after the balls leave the platform is, now this diagram is given, and now let's proceed to the solution. We can apply the conversion of angular momentum formula, and we can write it as 2mvr minus mr square by 2 omega is equals to 0. This is by applying conversion of angular momentum. We can write this formula. Now from this we can derive the value of omega, that is 4m Vr divided by mr square. Now substituting the values, we can get omega is equals to 4 into m was given in the question, that is 5 into 10 to the power minus 2 into 9, that the velocity, into 1 by 4, that was the radius, divided by 45 into 10 to the power minus 2 into 1 by 4. From this we can simplify it and write it as omega is equals to 4 radius per second. This is our answer, and the rotational speed of the platform in radius per second after the balls leave the platform is 4 radius per second.